Welcome, everybody. Thank you for coming. I'm trying to figure out which ones are talking the most so I can find something to yell at or throw at. Probably is Roger, but welcome, everybody. Um, First, like normal, I got to tell you about upcoming events. And we've finally got some stuff coming. Weather's getting nicer, and we got a building for an antenna build. April 26th will be a fox hunt. It will be a multi-stage fox hunt. The plan is, I'll get more details out. We're going to start probably around noonish with a high-powered jerk on the air that we need to find so we can get him off the air. Once we get to that location, there'll be a low-powered fox for people to find. We'll have a late lunch, and then for everybody that's interested, which hopefully is everybody, there'll be a more technical one using skills. So you'll get a clue, like maybe there's somebody operating on the input to the ISS repeater. So you're going to have to find what frequency the ISS repeater input is on, listen there, and hopefully find that fox, which then might give you a clue to a second one or a third one. So I hope it's going to be a lot of fun. I think it will be. Yes, sir. I think we're going to start at noon. I'm 99% positive. We got to finish the details. We just got it set up a little while ago. Let's say we're going to start at noon. It's April 26th. And the initial rogue operators, we call it, we'll tell you what frequency they're on. They'll be located somewhere in Canyon County, but he'll have a radio that he can bump up to at least 80 watts part of the time, so you should be able to hear him from anywhere in the valley, but his power level is going to change. How long the transmission is going to be very variable, because it's going to be a jerk that we need to run down because he's causing trouble. And it's going to be the same sort of thing when we get to the more technical side, that you may need to look stuff up, like maybe we'll tell you that he's interfering with APRS. What frequency is APRS on? Go there to find it. So a lot of real world side as well as just the fox hunt. We want to help you with different skills. Correct. As of right now, we're talking, we'll have a potluck type early dinner, late lunch at about 2:33. That's when the first fox hunt will start. Then for anybody who wants to do certainly. Then for anybody who wants to do the technical side, it'll start then. So like the technical side will start at, say, 3 o'clock. No problem. For anybody that wants to help as a VE, we've been asked to do some testing in Emmett the afternoon of May 3rd. I have no idea how many people they're going to have at the class. I don't expect it to be humongous. So if we have at least 4 or 5, 6 testers. Well, the testing will start at like noon, 1 o'clock, so the swap meet should be over. But, yeah. And then, yeah, all the good stuff will be gone by 6:30. May 10th, we will have an antenna. 980 West Center Drive, Central. I started, but May 10th will be the antenna build, which works really good with our thing tonight. We're still working on all of the different kits we're going to have as options to build. It will be in Middleton at the LDS Church building on Lansing Lane. We're planning, people can start showing up about 10 o'clock to start building. We'll have multiple, stuff set up like most of our builds, people to help with everything, antenna analyzers, soldering stations, potluck lunch. If you stay long enough, but we've got the building until like 3 o'clock, so we can plenty of time to build stuff and have a good time. We'll probably have a Fox set up out there, so if anybody builds like a tape measure Yagi, wherever it is here, you can actually go test it out. Should be a lot of fun. It normally is. Tell everybody you know about it. Now tonight we have the illustrious John Post, K7SKI, who just got honorable mention in the most recent ARRL antenna design contest. He's going to share that and a lot of other tips and tricks that he has on building your own antennas. So it's all for you, John.
I don't know if I can live up to that introduction, but I appreciate it. Yeah. Okay, my name's John Post. I've been a member of the club for several years, but my wife and I live in the Collister neighborhood. She is KB7FRF, and you'll hear us on Simplex once in a while. But she sends her best, but she fell about a month ago and has a herniated disc and a torn rotator cuff, and she's tough. Anyway, she puts up with me, so you and I are blessed in that regard. So I got my ham radio start when I was in the Air Force. I was stationed in near Rapid City, South Dakota. And one day, every third week, my squadron pulled alert, which is we'd live in a blockhouse by the runway. And if there was a national emergency, we'd run out to the airplanes and take off and save the world. But I'm walking down the hall one day, and I look into one of these rooms, and there's some friends of mine, and they were talking on a ham radio. And I noticed there was like a wire strung out in the tree outside. And I sat there and watched, and they were talking to one of the guy's dads in Texas, and we're in South Dakota. I said, wow, that's like, we do that in the airplane, but we'd have an antenna that's 35,000 feet in the air, So I hung around, and they got tired of me hanging around after a while, and I got to know our squadron intel officer. His name is Paul, K5LZT, and he pulled me aside one day after lunch, and he said, I hear you're interested in ham radio. And he said, I'll be your Elmer if you're serious about this. So I said, yeah, I want to know more about it. So he had me over and showed me his shack, and I was hooked. I had to do this. The testing and the structure was novice technician, general, advanced, and extra. And he was an extra class, so it meant he walked on water as far as I was concerned. But an extra class could give a novice exam. So I sat down after several weeks of study and had to pass a 5-word-a-minute code test, which is part of the process. Passed that. About a month later, I got my license, KA7SFX. And if you can do that without slurring your words, it was good motivation to upgrade, let me put it that way. Not long after I got my novice license, and I had to go to the base commander to get approval to put up a ham radio antenna at our base house. It wasn't a trifling thing to be transmitting in the early 1980s signals that could go around the world. So my friend Paul happened to be our squadron intel officer, as I said, and he carried a lot of weight as far as the base commander was concerned. So we went into the base commander's office and reported in. He said, oh, you want to be a ham radio operator? He said, I've always thought ham radio was cool. And I thought, okay, this guy's a full colonel, and I'm in like Flint. So within a week, I had a 40-meter dipole, which my little Heath kit could transmit on 15 meters and 40 meters, and I was off to the races. over time, you know, I got my technician and my general and advanced and eventually extra. But in that process, I found that the most satisfying thing I could do was build my own antennas. It was also an economic necessity. You had to be clever if you were going to put up an antenna on the base, so that added to my motivation. Fast forward now to the middle 1990s, and I'm working for Northwest Airlines. We're living in Minnesota. I'm very active in one of the local radio clubs, and I'd saved up enough money to put up a tower, and I did that, enjoyed all the benefits that come with that, and had one antenna up at the top of the tower. It was a commercial Ringo Ranger, if you've heard of one of those, and it worked great on 2 meters. 440 was still kind of fringe, not very many people on that, but it became a need in my mind for several other antennas up on the tower. I wanted to get as much vertical as I could, and of course the top position on the mast was taken. And I started looking at my new to me Mosley HF tribander one day, and I thought, where could I put an antenna? And I see this long, 25-foot boom just sitting there, not doing anything except holding the HF antenna elements. I thought, I could put something on one part of the boom. So I started toying with ideas. I had a hose clamp, I had a ground plane antenna, but it just wasn't really very satisfying. That I'd crawled up the tower and reached out, attached this little quarter wave ground plane for 2 meters with a big hose clamp that would go around the boom. One thing led to another, and I started designing this particular antenna. I'll get the newest one. This was a process. I didn't come to it all at once, but I realized that if I had a mounting plate that had holes in the bottom that were in a perfect square, I could take a hose clamp. I'm going to put this down. I could take a hose clamp or two in this case. And I could, you know, put them in like that in the holes and mount it on a horizontal, on a boom. All of a sudden now I've got 25 feet of possible antenna space. And of course you can reorient the hose clamps so that they can accept the vertical mast. And I was pretty proud of this. This was like 1995 or 96. So I'm still making copper J poles for friends, and that was one of the things that was very popular in Minnesota because do I need this? Yeah, please. How many of you have lived in the Midwest? So you know the thing about thunderstorms. Once in a while we get a thunderstorm here, but it's not what you call professional strength thunderstorm. You get the other side of the Rocky Mountains, and that's where they wrote the book on. Well, if you've seen the news lately, there's all kinds of drama as far as the Mother Nature's going on. So if you can, you want an antenna that's DC grounded, that will shed the static that builds up in some conditions, some atmospheric conditions. And I'll go back to the J pole here, and I'm going to pass this one around. I made this in 2003, and I took it down about 2 months ago, and it's a little bent in a couple places, but you can look at it, don't poke your eye, as my wife would say, but take a look at the wire, the feed point, and then the wire that comes up from the feed point goes in a coil around the longer element. Well, that wire is insulated, and it never makes bare metal contact with the aluminum. By wrapping it in a coil, and that insulated wire, by the way, is about 19 inches long. Does that sound familiar? 2 meter spans?
and it goes up 6 inches, bends 90 degrees, as you'll see, and then it wraps around the longer element. So it uses this inductive coupling to transfer the RF energy, but the rest of it is DC grounded. So it will shed the static that might build up on it. You have a little greater peace of mind if you're off in Minnesota or wherever in the Midwest, and you see a squall line come through, you think, oh, at least my antennas are right? So that was one of the innovations that I came up with. I have to give my Uncle Bob, W6FIV, who's now a Silent Key, but he and I were talking on the phone one day about how to accomplish this feed thing, and he said, try wrapping the wire around a couple of times. I said, should I rip it? He said, no, don't try that. But I hit on the 19 inches is the perfect length. And you know, from your experience, that's a quarter wave on 2 meters. So there you go. You have the adjusted J, so named because you can loosen the hose clamps that are on the elements and extend or retract the half-inch section of aluminum to meet the operating frequency. This particular antenna will take like 30 seconds to retune it for the GMRS VHF frequencies, if somebody is inclined to do that. I have made adjusted J antennas for the aircraft band, the Marine band, for VHF business band. It's a design I'm very proud of. And when I sent the article that I made, or the plans, into the ARRL before Christmas to enter their VHF antenna design competition, I didn't expect to get anything. At the end of January, this guy calls me. He said, where did you come up with this idea? I said, well, it's 30 years old. And I explained the background. He said, we're just all sitting around here looking at the base plate and thinking, how clever is that to be able to mount it on a horizontal tube or boom, or on a vertical mast. So, or you can use some light screws and bolts to the side of your fence. So, anyway, that's the adjusted J. It's going to be in the June QST magazine. Got the honorable mention, which I guess is 4th place. And I said, were there 5 entries in the? He laughed. He said, oh. So anyway, something I'm kind of proud of. But it was one of those things where you do something for almost 30 years, and then you think, maybe this has merit. Maybe I should share it with some people. So there you go. And we're going to figure out how to get the parts and pieces and put them together at the antenna building party. I've got some plans here. Read. Got a list of the places to get parts, pieces and parts. In 1992, I wrote an article about the copper cactus that I was building, the copper J-poles that I was building. I ran into the editor of 73 magazine, which wasn't in existence anymore. His name was Wayne Green. He came to speak at one of our Minnesota Ham Fest, and he was looking at my J-pole and said, that's really unique. Why don't you write an article about it? I don't think it's that special. But this is the copy of the 1992, it's the first page, 1992 article called The Copper Cactus J-pole. I didn't invent the J-pole, but it seems like the name copper cactus, which I coined, or Wayne Green, the editor, said, well, let me see your copper cactus. So it's been a lot of fun working with the J-pole design. This one's for 220. This one's for 440. You come and look at it, you'll see that it's got a phased upper section. The reason I did that is because the J-pole has a radiation angle that takes off a few degrees above the horizon. Makes it great for contacting mountaintop repeaters and so forth. But in order to get more gain, it's easy mechanically to build a UHF design that has a phased upper outlet which lowers the radiation angle, and you get that much more performance. You'll notice that it has the more conventional feed point design, something that's common to a lot of VHF copper antennas. You see this one here for 220. It's because the coil gets real fussy in UHF frequencies. You can do it, but you're going to spend probably the better part of the weekend trying to get it perfect. And it's just, you reach a point where on UHF frequencies, things start to act differently. So anybody that's built antennas for a while will appreciate that. Real quick, got a couple other, I've got some Yankees here. I've got some, one for 900, 2 meters, 440. And I have some little jigs and aids, I'll call them, for drilling nice straight holes in the elements to improve your design. And one thing I discovered, so if I'm going to make a lot of antennas, or anybody's going to make a lot of antennas, whether it's your scout group or your ward or your radio club or whatever, make a jig to hold everything in its place. This will hold the elements to the J pole. This will hold the elements to the for the boom, let's say. And so with the drill press or a hand drill, if you've got a steady hand, you can have something that's in place. It's nice and solid, and you're going to get a design that looks professional. So I've got other things in the literature that I've got here. One website I use if you're building Yankees is K7MEM. He has a wonderful setup right on his website. You put in the criteria you want, frequency, the diameter of your boom, whether it's like a 5/8 or a 1 inch, whatever it happens to be, the operating frequencies you want, and it will give you the length of the elements, where to place them on the boom. Easy. And that's what it should be. None of this stuff is super secret. Like I said, I'm not the one that invented all this stuff, but maybe just ultimately designed to make it more attractive to some people to use. Mike, do you want to talk about your antenna here? This is amazing. So everybody can build antennas. We'll just Greg Chu afterwards, if you want to come up and talk to me about some of the things that I've done, I'd be happy to do that.
So Hoot and I started on this antenna together, and I went to D&B and bought the longest piece of square tube that I could buy, and then I went to the Yagi calculator and figured out how many elements that I could put on there, and I wanted some way to be able to hold it at the back. So the spacing worked out okay. These are all copper pins, so they will move if I'm dragging it around with me for something like this. This is for 1.2 gigahertz, and I was talking from Grandview to Larry right there when we had the VHF contest, like we're talking to each other right now. The hardest thing for me to figure out how to do is to build the gamma match. It's described as a capacitor. That's how it works. But I could not figure out where I was going to solder a capacitor to that thing to make it work. So I learned something how to make it to the right frequency. The extension from the driven element to the capacitor is 2 ring terminals, and I soldered the 2 of them together, and now my element does not move anymore. It's nice and rigid, and that took me like 3-4 months to figure out how to get it to go on there and be solid. The spacing from the driven element to the gamma match is frequency dependent, as well as the length and where it's at when it taps the driven element. So there's quite a bit of math and science that I had no idea how it worked, but I'd seen commercial ones and I said I can build it. Then I wanted to be able to put it on a mast and keep it straight. So I went to Lowe's and I got me a shelf bracket, and it now stays out there the way it's supposed to, and it's adjustable. I have another clamp that I put at the bottom right there so that it's on my paint pole, and it works really, really well. I really like this in there. And I used SMA fittings to get it extension out to be able to tap it into my radio and then go into PL259. So that's what I built. That and all of the elements are straight directly through the mast and then soldered on both sides. The hoot and I drilled all the spacing of the elements out at the same time. I think Mindy's still mad at us that we got shavings on our carpet.
Oh, yeah.
Or no, we did. Or I did. I did. Not you. I did. Not you. You did.
What are the elements made of? What are the elements made of?
They're made out of copper rod.
Okay.
Just regular copper rod. I went to, again, to Home Depot or to B&B.
Yes, sir.
Yes, sir.
The driven element, is it insulated from the bar?
No, everything's grounded to the mast. Everything is insulated except the capacitor.
Right.
And that's why you have the gamma match.
So there's a piece of regular insulated wire that is cut the length of the driven element, and then I had to find a piece of vinyl insulated stranded wire that would fit that tube over the top of it. And for that frequency, it has to be that diameter. You can't make it bigger diameter because it's 1.2 gigahertz. If it was 2 meters, you could have a big tube. And then once that I got the spacing to be strong and be able to be adjusted, I found the sweet spot, soldered it in place, got everything straight, and it works. But it took me a long time to get that part of it figured out. I can get the gamma match tuned, but I couldn't get it to be there reliably. And it has to be solid in place so that it'll keep the tune as it goes.
Mike, did you use a program to figure out?
Yeah, there's a Yagi calculator. There's several of them.
Similar to the one that I had.
It might have been the one you shared.
Yeah, they all work the same.
Yeah, it's just an Excel spreadsheet. You put in the quantity, you put in the frequency, you put in how long your mast is you want it to be, and it'll tell you how many elements and what your gain is and all that kind of stuff. So I knew that I wanted to try and 1.2 gig contacts are worth way more than anything else. So I wanted to have as good of an antenna as I could possibly have for that frequency. So, and it fits on a paint pole. I went to Home Depot, bought a paint pole, and I put that on the top now, and I'm able to get the most distance out of it, string it up there about 30 feet. Works really great. Tie everything to the side of my car. Works great. Jacob and I, we wanted to make an antenna, and he wanted to do some satellites. So I told him, I said, the Arrow antenna, you can buy it commercially. I said, but I'm going to buy the Arrow elements and make my own. And everybody said, oh, you can't get aluminum arrow shafts anymore. You can get all you want, but they come from China. So I got on AliExpress, I bought a whole bunch of those, and then how am I going to attach them to my mast? So I took the part of the elements that you use for attaching your arrowhead. I put those inside the tube, and then how am I going to keep them on there? Well, I use the same crimper that you use for putting a SO239 print style fitting onto a piece of coax, and it makes a beautiful little crimp on there. It looks like it was supposed to be like that. And I got screws that went all the way through, and now I'm able to screw the two of them together, and the element stays. The next thing that I want to do, and again, I used the same information that I had with building the gamma match here. The next thing that I need to accomplish is make a harness to go from both of the two elements, two driven elements, to connect one radio. that harness will be frequency dependent because you're going to make a Y cable out of it. And depending upon how long it is, it's going to make the frequency change because it's going to take some of the energy to the 2 meter side if we're talking about 440. So it's like a phasing harness that you got built. So I think I maybe got $20, $30 into this antenna, but I did have to have all the elements come from China is where I got them from, and they were not hard to do. You don't have a lot of arrows that are longer than that, so I had to plan ahead. My drops from these arrows were able to be neck down to make the driven elements for 440. So this is my next Fox Hutton antenna is what I plan to use it for. So that's what I got there. I don't have anything else, John. You got anything?
Sure, I can.
I do want to say the first time John and I talked was when I just got to my general upgrade, and we met on the radio.
Yeah.
We were working field day from Bogus Basin, and I was from my house, and he had a signal that was close and hard and easy to get, and so that was the first time him and I spoke.
Yeah.
Right after my general.
It's fun. Anyway, well done. That's beautiful work. A lot of things are vexing, problematic when people start to, they say, hey, I want to build an antenna. A lot of times you just, where do I get the stuff? Where do I get the round telescoping tubing? And I've got a little sheet of paper that has supply sources on it. We're blessed in Boise to have an outfit called Gem State Metals. They're down in Garden City, actually. And they can order in telescoping tubing, but what I've seen them order in is not as shiny and bright as what I get from DX Engineering or Texas Towers. But I get my flat plate there in Garden City at Gem State Metals. Copper tubing, Ace Hardware, Home Depot, Lowe's, whatever. This is for 220 if I didn't mention it. And again, it has the phase section on top. And that's what I use with my 2-watt HT to check into the net 220 on our roof. So you can do a lot with a good antenna. Does anybody have any comments, questions, anything? We've got this, the tape measure Yagi, which is incredible. It's just evidence of what you can do with some forethought and some common materials.
Just start moving up and down, or the tube goes.
Anybody have any questions, comments? Feel free to come up and look around at the stuff that we brought in. There's this your group, infant halfway farms. Do you want to talk about that?
I can.
So
when it comes to do-it-yourself antennas, most of this is VHF, UHF. How many of you want to do HF radios? Wow, almost every hand's up in the air, that's good. What is a decent, inexpensive, multi-band antenna for HF? Trapped vertical is a good one. How about an infant halfway? Cut it for 40 meters, and what all bands does it work on? 40, 20, 15, 10. This is a 49-to-1 ballad. That's how hard it is to build. Real simple. Toroid, wire wrapped around it.
You do bifiller, so if you notice, 2 of the wires are wrapped together. That's the bifiller part. And then the other element goes all the way around, and that's your feed to the antenna. And the capacitor on it actually helps it on 10 meters, helps keep the SWR low. Normally when you do something like that, this one's actually a 9-to-1, but you mount it in a little electrical box just like that. And you can pull the top off of that and look at it. That's a 9-to-1. If you've heard of like the random wire, normally you use a 9-to-1 balun on that. And if you notice, the build is almost exactly the same other than the wraps of the wire. You can do that same thing to make a common mode choke or balun for just a standard dipole. You use a toroid in there. I was going to bring one of those, but ran out of time. And of course, like John talked about, who's ever played with the tape measure Yagi for direction finding? What a simple, inexpensive antenna to build. Beta match for your matching to bring it to 75 ohms. And the nice thing is when you hit the tree, when you're running to find, it bends, it doesn't break like Mike's fancy one, which is a great antenna, but I'll run through the brush with this one and I don't care, because when an element breaks, all I got to do is find another broken tape measure to replace it. Great little design. I built one of those for 220. I haven't built one for 440 yet, but I built a 4-element one on 220 that works good. There's lots of fun things you can do for building antennas. Normally the hardest part is the matching network if you can't build it to 50 ohms, but you can find stuff on them. So that's what I had. Come up and look at everything. You got anything else, John?
Nothing that I have here is secret or proprietary. If you want to take a close look at the jigs that I built 30 years ago or so, please, by all means, take measurements of the antennas or anything like that, but I want you to know that all of this stuff is open for intellectual sharing. And if you have any questions about building the Yagis, I'm happy to help with that. One thing that I didn't mention is make an investment in a benchtop drill press. They're not very expensive, but oh my goodness, that in concert with the jigs that I made there, make sure you get the nice straight holes. And the pinnacle of evolution as far as antennas go, right here, Hoot. We want to model this. Yeah, put it on. Put it on. Yeah. Well, you used to have. Yeah.
Oh yeah, this is, I put this on a Facebook page. This is what happens when you have too much time on your hands one day and you're getting ready to recycle a frozen 510.
See why I keep all that crap around the house?
So I put the chassis mount in the middle of the 510, measured out about 6.5 inches of insulated wire, which happens to be the same wire I've got on the matching system there for the adjustment J. I hung it from the light in my office and brought up the UHF repeater up on Schaefer Butte, full flatting. So pretty expensive.
That's why you never throw anything away.
Yeah, my wife would kind of agree with that. Who has an old trash can in their shop, in their garage, where you put the little sections of pipe and tubing and wire and whatnot? Yeah, guilty as charged. So anyway, yeah. And of course, specific, if you want to build one for 2 meters, you have to steal a pizza tin from your kitchen. Anyway, there you go. And if you want to take, like I said, the plans for the adjusted J are here, and then some little flyers for local sources for materials or where I got my stuff. That's all.
Thank you, John. Look at that, that's questions. And like this, if you go to Arrow Antenna site, when they have the plans on how to build it, they have all of the dimensions to make it. I made one real similar to this, but I actually got a bunch of actual arrows and took where the head would screw onto it. It's an 8x32.
Oh, yeah.
So I just did that, and then when I took the ends, they're not as fastened as well, but I took the threaded insert rivets and put in there. They just don't hold as good as this.
Yeah.
But it made it real easy.
This is a work of art. Thank you. This and thank you.
Yeah, and you can get arrows in lots of different colors, so.
Yeah.
If your wife wants it in pink,
Yeah.
you make it in pink.
Purple.
So,
I like that when you handle it like that. I really like being able to hold on to it like that, and you can change the orientation.
kind of, look at the tape measure when I get there. I changed it a little, I put it in a 90-degree angle so you can hold it like a pistol grip. It's light enough to move around.
Ideally, I want to get like a bicycle handle grip is what I want to put on there. They make big ones for like utility piece of equipment stuff. So that's one.
Sure, you can still get those arrows from East Arrow.
You probably can, I just know, calling local archery shops, and you say, do you have any aluminum arrows? They say, no.
And I tried several places local. I got the inserts local, but I could not get the shafts local.
I still got some of them. I found them in an auction, and I bought lots of aluminum arrows in an auction.
You talk about places with a handgun, have a similar, use my tennis, I always had that.
Oh.
It's better without handle and on the shaft.
So what I want to do, how many of you have been out to Celebration Park and thrown the atlatl they have out there? Atlatl. It's their spear thrower. They've got the hay bale set up with a picture of a woolly mammoth. When the kids are out there, they get the woolly mammoth, usually at a school field trip, they get a prize. So they have aluminum arrows, exactly the same as an arrow, but they're about 5 feet long. I wish I could find them, because how long is half of an element for a 6-meter beam?
3.
No. It's gonna, well, a 6-meter beam.
About 54 inches, give or take.
Right. Well, no, I don't.
Maybe about a quarter wave.
Yeah, so is it, so, okay, 64, so 54, okay, so a little less than 5 feet. Their atlatl arrows are about 5 feet long. Making something as simple as this, a 3-element 6-meter beam, of course your boom needs to be a little longer, but you could make it just like this with longer elements. And they actually got those, I talked to them one time, they ordered them from the archery place in Caldwell. They don't do aluminum arrows anymore. But just thinking how nice that would be to get some like 6-foot-long aluminum arrows.
Carbon fiber.
To make it,
Holds up better over time, I guess. But it's not where the scraps were made.
just kind of neat. But yeah, everybody, anything you want to see up here, ask questions.
I did get some of those to make 2 quad antennas. I got the Knox and the carbon fiber ones to use them in spreaders to make 2 quad wire antennas for 2 meters and 440 and stuff like that. Yeah, and it's non-conductive, so it works perfect.
Come take a look at everything. Thank you for coming, everybody. We know how to build directional antennas now, so we need more people at the Fox side.
If anybody wants help with a gamma match, I'm happy to show you one